Thank you everyone for coming to this conference and for coming to this session. I will just ask for the people they are maybe a little bit behind or on the back of the room. As we are not that many and the room is small, can you please come forward so we will have a more interactive session? So for instance, guys, yeah, come. There is a lot of spaces here. Who comes first? Guess this one. No, you have already. Okay, so I will just start presenting myself, who I am. I know some of the people in the room, so they know me already, but maybe the others, they not. So the name of my company is Gary Forge. We are based in the UK, not EU anymore. And we are based in London. Possibly we'll need to ask for the visa to go back. Because I was born in Italy, I'm not British, so I will have some problems like you, yeah. And the main focus of my company is to be committed to open source. It means that I work with clients, we do projects, we do a lot of services, but main focus is to get a lot of experience and share the experience with the open source world. So just to give you some example of the projects we are involved with is Git code review, Jenkins Spark, Kibana, Avro, and many others that I didn't mention here. About me, I'm that guy, maybe with a better voice sometimes, because the weather in London is not that great. And you can follow me on those two Twitter handles, and I'm the guy that is writing behind the Git Code Review Twitter account as well. Okay, so first of all, I would like to start to explain to you what I'm not going to talk about. So, because if you were expecting some of those, I'm sorry. I'm not going to talk about those ones. So maybe you're still on time to go to another session. So I'm not going to talk about continuous delivery. So I will assume that you guys know what is continuous delivery. And the full example I'm going to show you is not a fully implemented continuous delivery pipeline, because that's not my focus. And the second, I'm not going to talk about code review, because I'm assuming you guys, you do code review? Do you do? How many of you do code review? Good. How many of you do continuous delivery? Good. How many of you delivers once a week? Or more. Once a week or more. Okay. Once a day or more? Once an hour or more? Good, guys. So you guys will know very well what I'm talking about. You're even better than us, yeah. And I'm not going to give a lecture on big data either. Because again, I'm not going to explain to you what is big data. I'm going to tell you exactly the problem that we are facing and our idea on how to tackle the problem using some of the big data technologies. But I would like to make it very interactive. It means that if you think that I'm saying silly things, you say, Luca, what are you talking about? That doesn't make any sense. I've got different experience. I want to be really interactive. So the question is, so what? Why this guy is coming from the UK, outside the EU, and coming here to talk about what? There we go. So first of all, I'm going to show what is the type of continuous delivery we implemented, right? Because maybe it's different from yours. So maybe the problem we were facing are different from the problem you are facing. So it's better to focus on what was the scenario. Because even when I was preparing this presentation, other friends that were saying to me, but that's overkill. But I say, think about the scenario. Do you still think it's overkill? They say, no, possibly not. Second, we'll try to learn together. So I'm not going to make a lecture. We want to exchange our experience and learn together how to solve the problems that, for instance, I was facing, maybe you are facing as well. Then we'll do some experiments together. So the first two parts are supposed to be short, and we will do a lot of experiments together, and I will use some Docker machines. And I will show you as well how I build up the experiment, because sometimes Docker is good for experiments, but sometimes can be used in production, and someone knows very well. Yeah. How many of you are using Docker in production? That's good. That's good. How many of you are using Docker as experiments, maybe in Playground as well? Yeah. You should think about production as well. It's not scary. And the last part is, we don't have so much time, so it will be just 10, 15 minutes, some discussion at the end to see, let's say, what I achieved, what do you think I didn't achieve, what you guys have achieved with different approach, and so on. Okay, so let's get started. So first of all, that's the style of continuous delivery pipeline that we built. And this is not in my last project. So this is, for instance, my last project, it was with a startup, a social startup. This was for the previous project. It was a very large, let's say, government enterprise in the UK. So basically, we were having different stages. The first stage was a code review. So nothing was going even into the target branch if we were not doing proper code review. And we'll see why we were doing this way, because we wanted to achieve what is called the stable branch. So we wanted our builds not to be almost green or often green. We wanted to be always green. Because if the build is not green, it means your continuous delivery pipeline cannot deliver anything, because things will break. Then when the code review was finished, then we'll push it to the Git repo, and we were doing all the unit test and integration test validation with Jenkins. When that was okay, we were then building a lot of Docker images, because the Docker images, they were really the ones that were then used in all the different integration environments. And when that was fine, we were just telling Mesos and Marathon, please can go and deploy these Docker machines wherever you know they are needed. And they were deploying this in a kind of pre-production environment. And the reason why we didn't go live all the time is because if you have implemented the continuous delivery pipeline, you may understand that sometimes the changes, they make sense technically, but they don't make sense for the business. Because for whatever reason, they say, listen, but I don't know, you implemented a new implementation of this specific microservice for this tax, and the tax needs to be effective in 3 days, not now. Yeah? So for whatever reason, using feature switches or, let's say, using different legs, we're not deploying live. And then we had different type of clients. We had mobile clients, we had web clients, all the different style of clients. And in certain ways, there are some type of application you cannot deliver every single minute or every single hour, because maybe the approval from the App Store maybe will take a little bit more. And that's the type of pipeline that we implemented as well on the source of the code. So whenever we were doing the coding, we were doing code review, we were doing the pre-commit validation, we were not doing pull requests. So it means that the people were actually building the code in their machines, and then they were submitting to the target branch for review. But before the code was going to be, let's say, landed to the target branch, they needed to be, first of all, validated by the build, and then reviewed by different people. And in order to avoid all the mess of pull requests with a lot of changes, I'm doing this, no, I'm fixing that, no, I'm fixing that, no, I'm reverting that, we're amending the same commit over and over again, okay? So in order just to go practical straight away, I just wanted to show a very small example of what we implemented. So, okay, you can still see that. That's not my normal voice. That's the London voice, yeah, when it's raining. Okay, so first of all, I built some simple VMs to show you what I was doing. So that is what the code review looks like. Okay, does anybody know what is this thing, this one? Do you know it? This is Gerrit Code Review. How many of you have used Gerrit Code Review? Oh, that's good. That's good. So for the people that are familiar with Gerrit Code Review, basically this is a very, I would say, Sovietic interface or even horrible interface, but it's very practical to show exactly how the flow works. Basically, the open view is basically telling you what is under review. And at the moment, there is nothing. There is nothing under review. And here, I just had a simple example of, for instance, of a plugin. In this case, it's a plugin to integrate with GitHub, just a plugin that I put here just as an example. And as you can see, there are not just one job, there are two jobs. One job is for building the actual branch. The second is just for verifying what is going into the branch. So just to give you then in this flow, so one job is actually building this target branch, this master. And the second job is just listening for whatever is coming as candidate for master. And for the people that are familiar with Gerrit, it's called REST for master. And then validating the stuff that is going there. And just when the stuff is green, goes there. In this example, I'm going to show you just from the point of view of doing the unit test. But we implemented this workflow for all the pipeline. It means that for whatever change that needed to be candidate to go to a certain environment, that means the integration test environment, or the pre-production environment, or the production environment, there was a set of validations that were going automated through Gerrit. So the workflow works in this way. So whenever there is someone that wants to make a change to a project, so they go to the project, they do the normal clone. So for instance, I'm doing this clone here. There we go. And just copying the command and go to my command line. There we go. Can you see the fonts on the terminal? Should I make it bigger? Enough? Okay, okay. So let me do a clone. Hopefully it will work. Yes. Okay. And then whenever I want to make a change, for instance, do a silly change. Let's just break this POM file. Okay, yeah, I want to break these POM files. Silly change. So something will break for sure the, what did I do? No such file directory. This is the demo effects. Oh, yeah, I know why. I know why. Let's do... just 1 second. Let me do one thing. Hooks. Let's do... Yeah, let's move this one. Comment message. Here we go. Okay. And then let's do. Okay. Okay, and the last bit. Sorry for this small inconvenience. Yeah. Oh, I can copy from somewhere else. Get hooks comment message. Okay. Okay. Okay, so whenever you do a change and you push, instead of pushing directly to the target branch, as I shown before in the flow, you're pushing to this very special ref that is called RESTful master. So basically, this is really the start of the pipeline. This is really the entry point, the gate. So you never go to the branch. You go and ask your pipeline to say, I would like to go to this branch. And then the pipeline will start doing a set of validation of your code. And that happens all automatically, and you will get all the feedback exactly here on your open changes. So you will see now that there is one element in the queue. So basically, if things are going right in the right way, this queue should be very small, because the things are, the list of things that are piling up for being validated should, let's say, get validated or removed. It's like a flow of things that are going from the source to the sink. And this one, for instance, was a silly change. So you can see that someone has already validated this change. And it got already a score that is called verified. So this is, for the people that are not familiar with Gerrit, this is a big difference between the traditional system of pull request. How many of you are using pull request? Yeah, many more people. So you should think about leaving pull request, because pull request is a good thing for discussing about changes. But when you need to do continuous delivery, you need to have serious and clear rules when things are going right and things are going wrong, when things can proceed to the next step and when things cannot proceed. Sometimes in the pull request, there is a lot of interesting discussion, and then after all these messages, you wonder, okay, what should we do with this change? Should we merge it or not? Then someone pressed the merge button, and then you realize they were screwing up everything. But you just didn't follow all the discussion. Here it's really clear. You got someone that says -1. whatever is negative is, of course, let's say, something that forbids your change to move forward into your pipeline. Whatever is positive, it means that it is verified. And whenever you can go to the next step, you will see some buttons that are popping up here. So let's have a look. Who was giving us these verified -1? So it was not a human being, but was actually Jenkins. So just the fact that I published a specific change to Gerrit created a specific build that was triggered. Then by clicking the build, I can see exactly what happened. So this one was actually my silly change. There was an output. And the silly change didn't work because I just messed up, let's say, the POM file. So the author or the change can either go back to the command line and edit the change, or they can do as well online. So I can go here, and I can see what is the problem. I can fix it straight away. So Gerrit includes an online editor. There we go. Let's save it, close, publish the edit. So as soon as I do this, on Jenkins again, a new validation happens. So it means if we go on the other side, you'll see that here, a new build is getting scheduled. And for every build, you will see a specific link on the right side that says exactly why this build was triggered. Because in this case, it's not a build against a target branch, but it's a build against a candidate change. Then the build gets executed. Then we'll parse the POM. This time, hopefully, we'll say that everything is fine. And it will give me my positive validation. And whatever happens, you don't have to, let's say, leave your environment. So the developers basically stay on Gerrit all the time to see exactly what's going on. Because whatever happens on the continuous delivery pipeline always gives a feedback to Gerrit. So we have a lot of validation steps. The verified is just the one that I implemented here, the default for this presentation. But we have a lot of different flags. And whenever you move forward to the next step or the continuous delivery, you get a green flag or a red flag. And in this case, it says that I've got something new here. So let's refresh this page. And I've got a verified +1, because this time the build was successful. Then, as you can see, more actions on the pipeline are enabled. In this case, I'm able to do the manual code review, so the people can say this makes sense or not. We can just approve it. And then I can do a submit. And when I do a submit, it disappears from the input queue. It's not here anymore. It is on the output queue, because now all the code review process has been completed. And maybe some water will help. And on the other side, then shortly, the target branch will build as well, and will do the deployments. Okay? So that's the style of continuous delivery that we implemented. Okay, again, this was a small example, but imagine this one scaled up on, so those were the components. Imagine this type will be scaled up to our reality. Our reality was we had, and we still have, possibly even more, over 100 microservices and components. How many of you guys are using microservices? Stand up, because this is something important. Microservices, stand up. I'm really sorry for you guys. We are feeling the same pain. Because everyone says microservice is great, yeah, because you can deploy all the time, multiple times a day, nothing breaks. But then the problem that people, they don't understand is that breaking a big monolith into a lot of services, yeah, you break the complexity into a single service. But they forget about that a union of hundreds of components is much more complex to manage than maybe a monolith. That's why, for instance, large projects such as Facebook, they said, microservices, I don't need them. Let's do a monolith. It's nice. Even Google, many times they say microservices. What is this stuff? Let's do a monolith. But we had to do microservices because, let's say, we were coming from a monolith experience with the government, and then we were saying, let's do something new. Let's do microservices. Let's see how it feels. It feels really, really painful. Then we had, then obviously, over 200 repositories, now possibly even more, because maybe one service is not just one repository, maybe it's 2 or 3 or 5. And of course, we had hundreds of people, because these microservices, they're managing all the services of the government. So it's really, really big. And you can imagine, let's say, with 300 people, you can have hundreds of thousands of reviews and builds and so on. And then, of course, it got all the dependencies. And people say, no, microservices, they don't have dependencies. They're all independent. Yeah. They are independent in terms of build, but they are dependent one from the other in terms of runtime. And that makes your life, for the guys that were doing microservices, even more difficult. Because before, at compile time, you can rely on all the integration tests you were doing in your application with the mocks, and you are absolutely satisfied. But now, you need to have the real thing. Because maybe one microservice is in Scala, the other is in Node.js, the third one is Java, the fourth one, they started using Kotlin. Oh my gosh. And then you really need to have the entire microservice to understand if it really works or not. And then you can understand this starts creating longer and longer build chain. Yeah? And you need lot of resources. Maybe Intel was really promoting microservices, so can sell more CPUs and so on. And then, of course, you got tens of thousands of builds every single day. That's painful. That's painful. OK, so I just listed here some of the problems that were, just to say, calling me every day. But again, in the next phase, when we start getting interactive, you will tell me all your problems, that maybe there are much more than those ones. Or maybe you don't have this one, so you have others. So the first one was, this was the typical message every morning. Oh my gosh, it was working 5 minutes ago. Then what happened? I didn't change anything on my project. Someone has changed something, then the production doesn't work anymore. Not completely, something doesn't work. That's the beauty of microservices. At least something works and something doesn't work, always. Everything works? Never. Yeah? Then the dependencies. This is really, really a big help because every component then needs a different version of the service. So in a previous experience, in a previous project, we were used to deploy multiple versions of the service all the time in order to avoid this problem. But then you understand the number of, let's say, instances and the type of technology you need to use. We had to use OSGI. It becomes really painful. And then you're wondering why on earth I decided to go microservices, because that's really difficult to track it to understand. Sorry, just a little bit of water. And that's the most important question. Oh my gosh, but now, as the microservice becomes smaller, I need a lot of services just to test end-to-end the functionality. Because the product owner, at the end of the day, doesn't talk about the language of a microservice, talk about the language of a user journey. And maybe a user journey involves 50 or maybe 60 microservices. Where can I find a system to just deploy all of them? Can they fill my laptop? I don't know, maybe I need 32 or 64 gigabytes on my laptop, right? Or maybe I don't need a laptop, let's run everything in the cloud, but then the bill of the cloud will go up. And then cycle time. So all these difficulties is making the cycle time very, very long. It means that the time for the product owner to say, I want this feature, from the time where the feature is in production was becoming not hours, not days, but maybe weeks, and sometimes even months. Because maybe a small step was done every day, but the end-to-end feature wasn't ready until, let's say, all the single pieces, they are all connected together. And there's always something that breaks if the microservices are too small. Yeah? And the end of the story, the last was, if something breaks, going to your debugger on your IDE doesn't work anymore, just because debugger tells you just the story of one service. But in order to understand what's going on, you need to see exactly what all the other services were doing exactly in the same situation. So whereas before with the monolith, you were just going using the IDE, maybe IntelliJ or Eclipse, whatever you want. When you start going with microservices, you need to be used to go and drown in an ocean of logs. And then you don't know really what to do because they become so overwhelming. And then even if you publish all of them on Kibana, you go on Kibana, you look at Kibana and say, now what? What do I do? Oh my gosh, it's not easy. And the last one was then take all the 5 problems together, just melt down. Sometimes you just really want to die. Yeah. Okay, so we needed to tackle this problem because we were growing and we couldn't afford saying to the client, listen, let's go back to the monolith, because we were saying, no, the reason why we called you is because we're going away from the monolith. It was too expensive. So we said, okay, why don't we reuse some of the technologies that we know and we use in other projects, not to implement software, but just to tackle the problem, just to help us manage this piece that is called managing a service of, no, managing a pipeline of delivering a microservice-based architecture. So first of all, we said, okay, why don't we start collecting all the logs of everything? So code reviews, get whatever is getting there and put in the logs. Whatever Jenkins is doing, get it out of Jenkins, put to the logs. Whatever the runtimes are doing, get all of those and put into the logs. So know that at least we can get all these different rivers or logs going all in different directions and just put in the same bucket. Then the second problem is, oh my gosh, now I've got this central bucket, the bucket is really big. So I need to understand, before publishing those logs, I need to crunch them. So I need to be able to do, let's say, some correlation between different things together. And I need to extract what this information is relevant to me. And then when I've done that, I need to display in a much more, let's say, every real-time possible fashion that I can. So I can use maybe ElasticSearch, I can show on Kibana, but not the raw data. Because typically the people they get from maybe Jenkins to Kibana straight away, they have got a flood of logs and they don't know what to do. We say, no, we need to go to that level. Once we understood what the logs are, we correlated them in a useful way, and we extracted the meaningful information. So that was the experiment that we did. And I'm going to go through the experiment with you guys, because, again, I want to show you the methodology that we followed, because maybe it's not good, or maybe you've got something better, or maybe, let's say, with your feedback, we can improve it together. So first of all, to run all this environment, I can do it on this laptop, so I need to connect to a much more powerful machine. Okay, just to give you a feeling of this machine has 12 CPUs and 130 gigabytes of RAM. This should be, let's say, more than enough. Okay, so this environment I called Get It Central, because it's really like a place where I want to do all these continuous delivery pipeline all together. I want that all integrated together. And I want, let's say, to become my central point where I can exactly understand what's going on. And here, I started to create the different machines. So the first one that you saw was the Gerrit review machine. There we go. For the people that are familiar with Docker, that's the Docker file. So basically, every Docker file starts, let's move to the right side. There we go. Yeah, every Docker file starts from what is the base image. So this base image is coming from a Gerrit code review system. Then I wanted just to get some additional plugins. So just to mention the plugins, so first of all, I wanted the RabbitMQ plugin, because I wanted to get all the information out of the code review and inject into some message queuing. So why we go through queuing and we don't go straight to ElasticSearch? A lot of people, they go straight to ElasticSearch. How many people know what is ElasticSearch? OK, so that's good. And I don't need to explain. So we don't go straight to ElasticSearch because, first of all, as I said, we want to process the data before going there. And secondly, because maybe we want to trigger some other information. If you put in a message queue system, then you can have other agents that are waiting and listening from this message queuing system, and things becomes even more more resilient, because let's say Elasticsearch is low or is going down, is overwhelmed, the information is not lost. And then the other, OK, just another plugin just for displaying the code here. And then I was just initiating everything. In terms of the configuration, I needed to ingest as well the configuration where to put in the information. So in this case, I'm pointing to localhost, but in reality, the localhost is a Docker machine, right? So it means that it will just expose to where Elasticsearch is. And I'm going to publish all the events into exchange that is called Gerrit events. On the other side, on Jenkins, I've got a fantastic Jenkins machine. That is very simple. It says, gets the definition of a Gerrit CI system. So this is exactly the same one that you saw before. That is a Jenkins pre-configured with all this verification and so on. And the only thing that I need to do is basically just to configure a more recent version of Git, because I need it for whatever reason, and just defining the user that I needed. And that's it. And the last part that I want to show you here is the RabbitMQ. That is very simple. You just say from RabbitMQ, I want just to install, in this case, just a minimal Python to set up some initial configuration. And in the RabbitMQ init, you got exactly what I wanted to do. I wanted just, let's say, to define the connectivity and to connect basically the queue of events that are coming from Jenkins, the queue of events that are coming from Gerrit, all together. Okay, in order to put all those machines together, then I used another technology. It's called Docker Composer. How many of you are using Docker Composer? Yeah, you should. For the people that are using Docker, not Docker Composer is really useful because it allows you basically to avoid defining all the runtime parameters of a Docker file. Whenever you define a Docker machine, the problem is the Docker file defines just what the machine should do, but then what the machine actually does in terms of parameters is defined with your command line. In this case, you avoid doing all of this. You can define all your different services here with all the parameters you want. This is just a sample. This is not the production password, right? And then you can even let them link them together with this concept of links. So you avoid all the problems of defining the networking because Docker Composite does it for you as well. And in this case, it's already executed, so we'll show you just live. The list of machines that now I'm executing is this one. It is quite big, but they are all created and activated by Docker Composer. So if I do Docker Compose now and stopping all the system, and if I do up, we'll just read the definition and we'll start everything together. And we'll connect everything together. And it means as well that if you want them to replicate the same environments in a different system, you can do it very easily in this way. Another thing that then let's start it again just to show you. Basically, this one just reads the definition of the YAML file. We'll just start up the environment. There we go. And we'll show you as well, let's say, in different colors, what the different machines are doing in this case. The last bit that we needed as well is the ability for Jenkins to scale, because Jenkins becomes just the orchestrator of all your continuous delivery pipeline. But the problem is Jenkins is limited, right? So we needed to tell Jenkins, listen, whenever you receive a lot of reviews coming forward from Gerrit, you need to be able to create a lot of different instances and become elastic. So what we did is basically to use the Docker plugin for Jenkins. For sure, all of you are using Jenkins, right? Yes, good. Someone is using TeamCity. I know. So basically, there is a specific plugin for Jenkins that is really, really useful. And in this case, if you're using microservice, you can't live without it. That is the Docker plugin. And in this example, I just used the Docker plugin. But in production, we are using the integration with Marathon and Mesos. Basically, that allows as well to have a set of different machines and create the virtual machines wherever you want. And basically here, what we are saying is, at the bottom, there we go. Whenever you need to create a machine, just talk to that guy, to that port, and they will create the machines for you. And then you create here all the different templates of machine that you need. In this case, I said slave because this is just a slave that I need to execute the builds. But in production, we had a lot of different templates of machine that we needed to use. Maybe pre-configured with microservices, a set of microservices that we know already work. And when we spin up, they're already there, waiting for us to be used. OK, so thanks to all these specific environments, we were able to get all the events out of the system and put into these message queue system. So in RabbitMQ here, I'm monitoring exactly how many events are coming through from Gerrit and from Jenkins. So for instance, let's start with Gerrit. Let's start monitoring what's going on here. So let's start again doing my silly change. I like silly changes. And there we go. So let's go back to my silly change. Here, let's just align. Here, I'm doing a reset because the last edit that I did was online, so I didn't have the code locally, right? So let me repeat my silly change. This time, we'll just put blah, blah, blah. Let's have a look what's going on whenever I move forward and I start to create a little bit of waves into my continuous delivery pipeline. OK, whenever I push a change here, we see that something happens already. Because you see message rates. So some initial messages are coming through to Gerrit, right? And Gerrit gets these messages and get the dispatch to RabbitMQ, and then will propagate something to Jenkins, because even Jenkins will start building something. So I'm expecting some messages coming through from Jenkins as well. Let's wait a few seconds. There we go. All the changes are coming from Jenkins. And as you can see, even if I see the rate of the messages that are going up, they're not queued, because RabbitMQ is just a way to get the messages through. And where do I put the messages? So I used another component that maybe some of you are using as well, that is called Apache Flume. Apache Flume is really useful because whenever you've got really a river of events coming from different directions, allows you to listen to different sources and put them together into a unique sync, right? In this case, I configured a specific Flume sync that goes to HDFS. So let me just connect maybe with another terminal. Okay, and I will show you. So here I've got Hadoop Spark Docker machine. This is a very basic one, so it doesn't have fancy UI, but it's really fast. And what I defined is a Flume config. The Flume config is the definition of where the rivers are coming from and where they are heading to. So in this case, I say, okay, you've got two sources of events. They're all RabbitMQ. They're coming from different queues. And can you please get and receive all the events in real time and put them where? And put them into HDFS. Does everybody know what is HDFS? Yes? OK, so HDFS is a way to collect logs for a very long time, right? So it's a storage with infinite, potentially infinite storage size, because it allows you to get a block of different machines that have your storage grow over time. And it's very, very optimized then for getting the logs, crunching the logs, even if they are at high numbers, because you can use a Hadoop cluster to process them. And in this case, I'm generating all the information into a Flume Analytics directory by organizing them by year, month, and day, and then getting them into different directories. So the messages that you're not seeing then on the queues, they went to HDFS straight away. And to show you that actually that happens, let's have a look. So if I do a Docker PS, I should go into the Hadoop Spark, this machine. And let's do an exec. OK, now I'm inside the Hadoop machine. And if I do Hadoop fs/Flume Analytics, you see that there is actually one directory, exactly the day of today. And inside we've got 03, because this is based in Canada, and it's 3 a.m. And we've got Garrett, and inside, there is no completion. We've got all the events. So here, as we generate a lot of events, we don't want to generate a lot of files, because every file system will blow up. So Flume as well allows you to aggregate and compress the data. So in a way that whenever you gather all this information, then is in a safe place that is stored for a very long time and is absolutely optimized. And then the way you analyze the logs becomes really, really simple. So in this case, I was showing a very simple example on how to use, for instance, Spark. But again, there are a lot of tools that you can use on top of that. So if you want, to say, hurt yourself, you go and publish straight to ElasticSearch and Kibana, and then you die. Or if you want to be a little bit smarter, so you read this information, and as you can see in Spark, it's really easy because you can use wildcards as well for reading. So you can read a set of files, decompress them on the fly, and automatically aggregate them. And then on that, you can do fantastic things, using them as they were just as simple tables. So you don't need a database. You just put the files there, and then you can do whatever you want. In this case, I wanted to extract some information from the changes and all the associated logs in the build. So I wanted to say for all this change that was going through the pipeline, I want to have all the logs, just in like it was in a table. So I'm creating basically two data frames. Data frame is an abstraction that Spark has to access a set of files and use them as they were a kind of table, and I get from the JSON that is coming from the different events, they are really complex, I'm going to select exactly the information that I need, and I give some meaningful names. So in Garrett, for instance, the change ID is called change.id, but in Jenkins it's called data build variables, Garrett change ID, and blah, blah, blah. And then I can do whatever you want. So for instance, I can store to ElasticSearch, I can filter them, I can do joins, I can do whatever type of analysis you want. And then once you've got there, you can display in Kibana with wonderful graphs in whatever way you want. OK, so let's put it in this way. It's not that our life has improved tremendously. First of all, because the weather is still shit in London. I don't have my voice. And second, because it was doing a little bit of help. It was going to help us in order to understand a little bit quicker what's going on. But for sure, there are still a lot of problems that still need to be solved. So let's have a look. So this is the type of implementation that we did in order to, let's say, help us a little bit. Let's double check. Did we solve all of our problems? So first of all, ripple effect. Do you think that I address ripple effect with this type of organization or not? No. And let's trigger a bit of discussion after that. Dependencies. Was it addressing dependencies? Yes? No. Resources? Give me a yes. Give me a yes. Yes. Why? Why was managing the resources? Because I don't explicitly indicate what type of resource I want, but I just ask the system that I need a resource. And whenever I want, then the system is going to Marathon or Mesos or Docker to say, listen, I need this. Can you just give me a machine because I need to verify this? And then that provides the feedback into my code review. But I don't have to specify, I need to deploy this one in this environment, this one in that environment. I just said, I would like an environment like this, and you manage yourself. Cycle time. Yes. Not because I reduced, but I understood what's the problem. Because many times, maybe a feature takes a very long time. When I mean cycle time, I don't mean just the build execution time, because that is really a very small part of the problem. I mean end-to-end. Log declaration, yeah, that's the purpose of the talk. Avoid meltdown. Yes, because I plan my holiday in a couple of weeks, so I can leave all this shit to someone else. Yeah. Okay, so these are ideas that I've got in future directions, but I would like to trigger some question answers, maybe answers. I may question, you answer. On, or even sharing your experience. What do you have done to sort out this problem, or what are your problems? So what I was thinking about was even collecting more data. So sometimes the cycle time is getting very high, not because the build itself is low, but maybe some other resources, they are really in short availability. Maybe it just increases some of the resources, you can get a much faster cycle time. Real-time statistics. At the moment, we're just running these jobs on a periodic basis, but we can start using Spark streaming and to get these statistics in real time. And then more feedback loop on code review as well of the statistics itself. So a specific change may get a positive or negative, even based on the fact that maybe it's making the overall statistics much worse. Imagine that you say, yeah, your change makes sense, but you see, before the cycle time was taking, I don't know, 15 minutes, and after your change, it's taking 2 hours. So maybe your change is not that good. So that information is really useful to be brought down to the developer. And more, what do you think? So what are the type of problems that you had? What do you think about this approach, or did you take a different approach? To you guys, that question more is for you. What do you think? Oh, that's good. That's good. Maybe with the microphone? Yeah. Can you just repeat the question, because maybe they've got recordings and so on?
Actually, it wasn't a question per se. I just said that I'm afraid of the amount of data. So we're doing a lot of fancy stuff, but we don't know a lot about it. So we realized we have to look into these kinds of things. But yeah, we're already generating incredible amounts or collecting incredible amounts of data, and our build logs, for instance, and things like that are huge.
That's a very good point, because there was an interesting talk last year in Santa Clara at the Jenkins user conference, because Google really wants to start using Jenkins. They haven't used Jenkins so far because it was too slow, and they're right, it's too slow. And they realized that whenever you keep a lot of history in Jenkins, and whenever you got builds with huge logs, the performance of Jenkins just going down so much. And actually, this type of solution resolves a lot of the problem, because you don't have to keep a lot of history in Jenkins anymore. You can just keep the last 5 builds. Because all the data, as soon as it gets produced in Jenkins, gets offloaded to RabbitMQ straight away and stored into HDFS. Yes, you will occupy a lot of this space on HDFS, but first of all, in Jenkins, the logs, they are not aggregated, they are not compressed. Many times the log always say the same thing. So if you manage to aggregate a lot of logs together, in the way to differentiate which log belongs to which build is not in the log file name anymore, because it is in the data. You were seeing that before. In order to correlate the set of logs related to a specific change, I was doing a data frame query. I was not looking at the log file name. Whilst if you leave the logs in Jenkins, they will occupy a lot of this space, the file system will blow up, Jenkins will become slow, and then you will wonder why you chose Jenkins at the first time. In reality, Jenkins is good for doing stuff that is done, let's say, I would say in the very, very short time frame. It means whatever happened in the past hour. But if you want to understand what's going on, for instance, the past weeks or month, HDFS is a much better storage because it's cheap. So typically in HDFS, you can use a cluster of very, very low specs machines because it's inherently replicated as well. So it's got as well the ability to recover from failures. So if one HDFS node goes down, the others they will just start replicating the data that was lost in the first node. And second thing is it's available as well in large scale for very low cost. So for instance, if you don't want to manage your HDFS, you want to just store in S3, you store directly in S3, that is HDFS provided by Amazon, and then you define your jobs to extract the information that is relevant to you with EMR in Amazon that costs basically nothing. For 1 hour of processing of logs costs $0.1. Nothing, really nothing. So the storage becomes not anymore a problem, can be, let's say, processed very quickly, and your Jenkins stay very lean and small, right? Other problems, or maybe ideas, or even just say you like, you think this presentation was useful? Yeah, the bottom.
Thank you. Your kind of continuous integration pipeline or infrastructure consists of a lot of tools, Flume, Gerrit, RabbitMQ. Yeah, how do you cope with the maintenance of all the versions? I mean, new releases, maybe you break something, yeah.
Yeah, so the answer is exactly the Docker machines and the Docker infrastructure. So we don't, let's say, deploy the different components one by one to physical machines, but all the versioning of the infrastructure is on Docker itself. So it means that whenever we go to, and we've got this organization of the Docker Composer with the Docker project exactly in the same way that Git manages a top repo and submodules. So basically the Docker Composer is the main repo and then tracks exactly what is the version of the aggregation of all different tools and has a lot of different submodules. And different submodules are the definition of the individual tools. So whenever you make a change, for instance, in a specific submodule, because you upgrade a version, you can, again, just check if everything works with the previous one. If that doesn't work, you don't update the pointer to the submodule. So let's put it in a different way. There is a pipeline to evolve the pipeline. But that one is much simpler, because by being all Dockerized, you've got a set of very, very basic flows, and you just measure end-to-end that if I put a change here, I'm waiting at the end of the day to have some data maybe showed in Kibana. If something breaks, you will see there. And all the different tools that we have seen, they are all available as official Docker images. So the Gerrit one didn't exist, and we created as Gerrit Forge and contributed to the community, and now lots of people are using Docker images for Gerrit, because historically it's been a complete mess to install it. Jenkins, even if it was really simple, you know better than me that sometimes gets complicated in terms of management. So Docker helps out in keeping track, for instance, of the plugins you need there and making sure that they are not breaking. And all the different components that we have seen so far as well, including the Hadoop, there are now a lot of very lean and small installation that you can use.
Thank you.
Okay, I think we are almost at the end. We've got just 50 seconds. Maybe last question, quick. Yeah, on the bottom right.
did you perform any steps into this topic, events correlation? Because it would be great if you could aggregate all the problems which have the same root cause.
Yes, so that one is really interesting because in terms of what we want to implement as well, is not just the part before the continuous delivery pipeline, but even after the rollout. So, because you can manage a lot of things before they break, but you can even act in a different way by saying, I can be a little bit more relaxed in breaking things and just being very quick in understanding what's going on. So we are already gathering all the information about the production logs, but we don't correlate. So by introducing these, let's say, temporal correlation in this case, because you see that you rolled out a specific version, and then maybe you watch the production logs for a little while, you can find some specific features of your logs you're expecting to happen. And if those features they are different, you can provide another feedback. One thing about Gerrit that is good, you are allowed to continue to rate and provide comments even on a closed change. Because sometimes you do a change, is approved, but at the end of the day, you realize that was really horrible. But then you're already live. So Gerrit allows you to put even code review feedback after that, because maybe you want to understand that even if your change was merged, then there were some problems in production, so you need to do something. So maybe you revert the change, or maybe do another follow-up change to fix it. There is something that definitely we are going to implement. And just one thing, so all the information that you have seen so far, we are going to publish on our GitHub, Gerrit Forge. So if you want to contribute, or if you want to replay the same thing that we have seen today, or you want to evolve, or you want to suggest a comment, you will be more than welcome to do it, okay? Okay, I think we are over with the time, and thank you very much for having come.